another video, and this time I made a software to create formula units for ionic compounds. So just before I start to explain and show you the software, I'd like to explain and tell you the chemistry involved behind it so that you can understand what the project is all about. So let's get to that. So to understand the topic, first we have to have a look at how atoms combine. So for that we'll have a look at the periodic table first. So if you look at the periodic table, you'll see at the last column there are these elements, that's helium, neon, argon, krypton, xenon, all in orange color. So these are all noble gases. So all elements have a tendency to get electronic configuration like noble gases. For example, if you take helium, helium has the duplet. So helium has 2 electrons lying in its outermost shell, that's the first shell, the K shell. And if you look at others, that's neon, argon, krypton, xenon and radon, they have all 8 electrons filled in their last valence shell. So the tendency of all elements is to have that kind of a configuration of their electrons in their outermost shell. So just in brief, just to tell you that suppose I have hydrogen, so hydrogen will have only 1 electron because it has 1 proton. That's how elements occur. So they have the equal number of protons and electrons. So if I have boron, it will have 5, carbon 6, nitrogen 7. Similarly, all others will have the same number of electrons as the number of protons. So if we look at chlorine, it will have 17 electrons because it has 17 protons. So you can see chlorine is very close to argon. So now what will chlorine do? It will try to get a configuration like argon, right? So argon has an octet. So octet means that it has 8 electrons in its outermost shell and it doesn't react. And other elements want to be like it. So if you have chlorine, chlorine has 17. So it requires 18 to just have the similar configuration like argon. So for that purpose, what chlorine will do is that it will take 1 extra from some other element. For example, if you have if we look at sodium, so sodium is just after neon. You can see that neon and then there's sodium. So if you look at sodium, it has 1 extra electron than neon. So neon has 10, sodium has 11. So if it can lose 1 electron, it will have a configuration like neon. And chlorine, if it gains 1 electron, it will have a configuration like argon. So if you look at a sodium atom, you can see there's this first 2 electrons in the first shell, the K shell, and then the other 8 electrons in the K after L shell, and then you have 1 extra electron lying in there in the extra shell. You can see that. And then you have the chlorine atom, in which you have the last shell filled up with 7 electrons. You can see 1, 2, 3, 4, 5, 6, 7, and 1 is still here remaining. It's like a vacancy. So what chlorine will do is it will try to get 1 electron from somewhere. So as we saw that sodium has 1 extra and chlorine has 1 less, they will combine and sodium will give 1 of its electron to chlorine, and you can see it gets an octet like argon, and sodium gets an octet like neon. So they both can exist properly. And now if you look at some others like magnesium chloride, so magnesium is it has 12 electrons. So it has 2 more electrons than what neon has. So what it will do is give 2 electrons to some other element. So we saw that chlorine has 1 vacancy. So what chlorine will do, with what 2 chlorine atoms will do, is that they'll take 1 electron, each of 1 electrons from magnesium. So magnesium has 2. So it will give 1 of its electron to 1 chlorine atom and the other to the other one. So that's how they combine. And now to write them, what we do is we just crisscross their valencies, because see, in that case we had magnesium, so magnesium had 2 extra, so its valency becomes 2, and chlorine has 1 less, so its valency becomes 1. So if you look here, magnesium, it has a charge, or say the valency of, it has a charge of +2 and a valency of 2, and chlorine has a charge of -1 and a valency of 1. So if you crisscross, you will get magnesium chloride, which is represented by a formula unit called magnesium chloride, and that stands for MgCl2. So what the project does, what the software does is that you have to just type in the name of your metal and the non-metal, and it will just show you the formula unit for that ionic compound. So let's just have a look at how it works. So here it says enter the symbol of your cation. So cation is simply a metal losing its electrons. So suppose we had magnesium. It says it's found and it says its valency is 2 as we saw, and it says enter your anion. So let's enter chlorine. So we get, it says valency 1, name chloride, and when they combine they form MgCl2 as we saw, and the name of the ionic compound is magnesium chloride. So that's not the only elements you can combine. You can combine a lot of those. So for example, I can say potassium, and then suppose I have acetate. It says it's found and it's called acetate, and when they combine they become potassium acetate, and they have the same valency, that's 1, so they don't show up as 1 and 1 after the name of the element. And we can have some others also, such as auric, that's gold, and if you have auric has a valency of 3, that means it has 3 extra electrons. So that's so auric, meaning gold, has to give 3 electrons to someone. So for example, if I have HSO4, that is hydrogen sulfate or bisulfate, so you'll get auric plus HSO4, that's auric bisulfate, and that's, you can see the valency of auric, that's 3, went down to bisulfate, that's hydrogen sulfate, and the valency of hydrogen sulfate went towards auric, that's 1, and it didn't show up because you don't write 1 after the formula unit or the element between each other. And this is what the project is all about. So hope you enjoyed it, and if you like it, please comment down below, and you can hope you enjoy the video. Please like, share and subscribe.